Boys and girls, this is Mr. Manise here again with another super amazing video, and in this video I'm going to walk you through how to do every problem on the Chapter 7 quiz review. My disclaimer is always, I need you guys to actually work these problems yourself first and then come to the video and see if you've got everything right or try to figure out where you might have gotten stuck. So don't just watch this video and copy down the answers. Alright, so for my Clemson reference, I have Powerade 0 calories. I have Powerade 0 calories. And look at these wonderful, beautiful colors. We got orange and we got purple. Orange and purple. Okay, anyway, orange and purple. Alright, so let's go ahead and jump right into the problems. Alright, so the first thing you got to do is figure out which land am I in? Okay, we've talked about three different concepts in Chapter 7. We got Pythagorean Theorem, a squared plus b squared equals c squared. That's when you have two side lengths and you're calculating the third side length of a right triangle. We have the special right triangles, the 45, 45, 90, and the 30, 60, 90. And then we have trigonometry. Okay, so when I'm looking at these first few problems, which am I going to use? Because I've had some students already say, well, how do I use trigonometry here? Well, I can't use trigonometry here because, well, I could, but it would take several steps. I'd have to use the inverse trig function and find the angle and then go back and use, okay, there's a much easier way. When you have two sides of a right triangle and you're just trying to find the third, that is Pythagorean theorem all day long, okay? A squared plus b squared equals c squared, okay? How do I know which one my c squared is? That's going to be the hypotenuse. Alright, so I'll label that, the long leg across from the 90-degree angle, as my C. And so I've got a squared, and it doesn't matter which one you label A and B, okay, because 3 plus 1 is the same thing as 1 plus 3, because I'm adding two things together. Alright, so a squared is going to be 5 squared plus b squared, which is x squared, and that's going to equal c squared, 8 squared. Alright, so that's going to be 25 plus x squared equals 64. I'm going to subtract 25 from both sides. I get x squared is equal to 39. I will take the square root of both sides, and I will get, now, throughout this whole quiz review, guys, I know some of you guys may be watching this video that don't have me as a teacher. Some of your teachers may be asking and requiring you guys to leave your answers in the simplest radical form, okay? I spent 10 years in industry working at a chemical plant. And I'm here to tell you that nobody, and I mean nobody, leaves answers in radical form, okay? This is one of my pet peeves about math, is I'm trying to prepare you guys for college and life after school, okay? So nobody's ever going to say that the length of this triangle or the length of this structure is 5 times the square root of 3 feet long, okay? That has no meaning, okay? Everything is converted to decimal in the real world. So for my students, I'm perfectly fine with you leaving these answers as decimals, although yes, we have our standards, yes, we're supposed to teach you how to simplify radicals and rationalize the denominator. And so I'm going to show you in this video, I'm going to show you both ways. Okay, I'll do it the radical way and then I'll do it the decimal way. But just know for my students, I'm fine with you leaving your answers in decimal form. Okay. All right, so the square root of 39. So if I want to type that in on my calculator, square root of 39, I get about 6.2. Okay. All right, so that has some meaning to me. Square root of 39, I don't know what that means, okay? But 6.2, now that I've converted it to a decimal, I can say, okay, yeah, I buy that because 6.2 is less than 8, okay? So that's got some bite to it. That's got some meaning to me. All right, so let's look at the next one. We've got number 2, we've got 4 and 4. Now in this one, actually I could use one of the special right triangles because since these legs are both the same, then this is a 45, 45, 90. So in this case, yes, I could use the special right triangles. But since these first 6 problems are about Pythagorean theorem, I'll stick with Pythagorean theorem. So these are this is my A and this is my B. The X is the long side, that's my C. So I'm going to say A squared plus B squared equals C squared, X squared. All right, so I got 16 plus 16 equals X squared. So I have X squared equals 32. Take the square root of both sides, punch that in on my trusty calculator, and I get x is equal to 5.7. I'm going to round everything to the to the nearest tenth. Okay, now that's got some meaning to me. 5.7, yeah, that makes sense because that's longer than both of these legs. Okay, if you had wanted to use the special right triangles, you could. Okay, and in this case, this is probably a little bit faster. So if you're ever wondering why do we learn these different ways, well, because that's the way it is in the real world. You've got different ways to solve it, and it's up to you to figure out what's the most efficient and the fastest way to do it. If you remembered that whatever the leg is, then the hypotenuse is the leg times the square root of 2, you could have just said 4 times the square root of 2, and when I type that in my calculator, 4 square root of 2, oh look, I get the exact same number. Okay, so always be looking to see, is there a faster way to do it? Okay, all right, so for this one, I've got 6 and 10, so I'm going to have to use Pythagorean Theorem on this one. All right, so remember, guys, the shortcut is, when you're using Pythagorean Theorem, there's only 2 different possibilities. Either A, you're going to, when you're trying to find the hypotenuse, you're going to square the A, square the B, add them together, and then take the square root. Okay, so when you're trying to find the hypotenuse, such as this case, I'm going to square both of the legs. That's A squared plus B squared. All right, that's going to be equal to x squared. So that's going to be 36 plus 100 equals x squared. 136 equals x squared. Take the square root. And the square root of 136 is 11.7. Okay. Again, you could simplify this radical, but for this year, guys, in 2007, the 2017-2018 school year, we actually decided to take simplifying radicals that we normally teach in the first 2 weeks of the year, and we put that on the back end of the curriculum. So I actually have not taught my students how to do that yet. So this is another reason why I'm perfectly fine leaving this as a decimal instead of trying to simplify this radical, because you guys, my students don't know how to do that yet. Okay, so 11.7, I buy that because it's the longer side. All right, so once again, when I'm trying to find the hypotenuse, all you do is you square that guy, you square that guy, you add them together, and you take the square root. When you're trying to find the leg up here, okay, you're still going to square that guy, but instead of adding them together, what are you going to do? You're going to subtract. So you do the big number squared minus the little number squared, take the square root. Square that, add them together, take the square root. Okay, number 4, Pythagorean Theorem. Okay, so I'm trying to find a leg. So what are we going to do with these guys? We're going to square them and then subtract them. So I've got a squared plus b squared equals c squared. I got a lot of students that not quite so sure what to do with the square root of 197 squared. Well, whenever you square a number, when you take the square root of 2 squared, you're saying that's equal to the square root of 2 times another square root of 2. When I multiply these two together, square root of 2 times the square root of 2 is the square root of 4, and guess what that is? It's just 2, okay? So whenever you square the square root of something, you just get itself. So in other words, the square root of 13 squared, that's 13. The square root of smiley face squared is just smiley face, okay? So down here, when I square the square root of 197, guess what I get? I get 197. And that's going to be equal to 16 squared, which is 256. And then what do I do with these two numbers? You subtract them. You take the big number minus the little number. And that's going to give me 59, and then you take the square root. The square root of 59, my calculator says, is about 7.7. Okay? I buy that because it's less than the hypotenuse. I always ask, does my answer make sense? Does it pass the lab test? Okay. All right, we're solving for a hypotenuse. So I'm going to square that guy, add them together, and take the square root. A squared plus b squared equals c squared. 16 plus 25 equals x squared. And so x squared is equal to 41. Take the square root of both sides. And my calculator says that's about 6.4. Okay. Do you buy that answer? Yep, because it's bigger than the 5 and the 4. All right, I'm trying to find a hypotenuse, so I'm going to square that guy, add them together. and take the square root. 36 plus 49 equals x squared. X squared equals 85. Take the square root, and that comes out to be about 9.2. And I buy that because it is larger than the 6 and the 7. All right, so that's Pythagorean theorem. Okay, down below you have a question or two like this on the quiz where it's asking you how do you know whether the triangle is acute, obtuse, or right? And you're simply going to compare a squared plus b squared. I'll put a box, and you're just going to compare that to c squared. If c squared is bigger, let me see if I can get, let's see here. Oh, I don't know if I can make a small enough triangle. Well, I'll see if I can do it here with the 2 pins. Here's a right triangle here. Okay, a squared plus b squared equals c squared. Okay, so this is my c squared, the hypotenuse of my triangle. If the hypotenuse squared is larger, bigger than the a squared plus b squared, what's going to happen to this triangle? It's going to have to open up to make room for this longer third side, right? So if c squared is bigger, think bigger, larger, obtuse, bigger, okay? If c squared is smaller than a squared plus b squared, then that means that triangle is going to have to close. This will have to be an acute triangle to make room for this smaller c squared. And of course, if c squared equals a squared plus b squared, then it's just a regular good old-fashioned right triangle, okay? All right, so how do I know which one C is? Of course, that's going to be my longer side. So I'm going to compare a squared plus b squared. I'll put a box with a question mark. I'm going to compare that to c squared. All right, so I have 64 plus 256, question mark, 289. When I add those together, I get 320. And I get 289. Okay, so which one is bigger? The 320 is bigger. Okay, so that means my c squared is smaller. C squared, this side is smaller, acute. Okay, that's going to be an acute triangle. Okay, which one's my bigger one? 75. That's going to be my c. So let me compare 60 squared plus 46 squared. Let me put a box. Let me compare that to 75 squared. That gives me 3600 plus 2116. I'm going to compare that to 75 squared, which is 5625. Add these two guys together, 5716 and 5625. Pretty close. Which one is bigger? Okay, the c squared is smaller. Always look at the c squared. Is c squared bigger or smaller? C squared is smaller, so that's going to be an acute, also an acute triangle. Okay, let's keep going. All right, more of the same. What kind of triangle is it? Okay, 61. That's going to be my C. So let me compare a squared plus b squared. Box, let me compare that to 61 squared. So 11 squared is 121 plus 3600. Compare that to 3721. Add these two guys together, and when I add them together, I get 3721 equals 3721. Okay, so if a squared plus b squared equals, then that's going to be a right triangle. All right, last one. What do you think this one's going to be? Well, we haven't seen an obtuse triangle yet. Let's see if they give us an obtuse or maybe another acute triangle. All right, so this one is the bigger one. So let's compare a squared plus b squared. Compare that to c squared. All right, so we got 46 squared, which is 2116 plus 3136. Compare that to 4900. Add those together, I get 5252. Compare that to 4. Oh, look. The hypotenuse is also smaller. That's interesting. So that gave us 3 acute triangles. Just remember, if this number on the right is bigger than these two guys, then it would be an obtuse triangle. Okay, so now looking at these next few problems, 11 through 16. Okay, what land are we in? Well, I see an angle. Okay, so if I don't see any angle at all, I'm probably thinking that's Pythagorean theorem, right? Well, I see an angle here, so your first response or your first thought might be, well, this is probably trigonometry. And let me see if I can zoom in just a little bit. Okay, so it's either trigonometry or special right triangles, but I see a 45 degree. Okay, if it's 45 and 90, then the other angle has to be 45 degrees. Okay, so I'm in the 45, 45, 90 land. And let's see if my webcam will come back to normal. There we go. Welcome back, webcam. Welcome back. Okay, so for the 45, 45, 90, guys, you only have two options. Let me draw it for us. 45, 90, 45. Whatever the leg is, both of those are legs. This is an isosceles triangle, so I can put ticks there. Whatever the leg is, the hypotenuse is the leg, and you slap on a square root of 2. It's the leg times the square root of 2. So there are only two options. Either I'm going to be multiplying by the square root of 2. If I'm going from a leg to a hypotenuse, if I go from a smaller side to a longer side, I got to multiply. That number's got to get bigger, okay? If they give me the hypotenuse and I go from the longest side to the leg, that leg's got to get smaller. So I'm going to divide by the square root of 2. So use that little trick on these 45, 30, 60, 90 triangles. Are you going from a shorter side to a longer side? That means you got to multiply by something. A larger side to a smaller side, you got to divide by something. So what are we doing here? What is this? Okay, that's the leg. So I'm going from the leg to the hypotenuse. Well, if that's the leg, then the other leg has to be the same thing. So that's easy. Y is also 5 times the square root of 3. Okay, so once again, guys, I'm going to do this as the decimal, and I'm going to do it as the radical way. Okay, so if I'm going from the leg to the hypotenuse, I have to multiply this guy times the square root of 2. Okay, so x is going to be 5 times the square root of 3, it's just going to be the leg, times another square root of 2. Okay, when I multiply these two radicals together, what do you do with the two numbers? I just multiply the two numbers inside. 3 times 2 is 6. Okay, so that's going to give me 5 times the square root of 6. Okay, that's the radical way. If you want to do it the decimal way, then this is what you would do. On my calculator, just go ahead. Some of you guys get confused when you see the radical in one of the side legs. Just convert it to a decimal. 5 root 3 is some decimal. So type 5 second square root of 3. Okay, 5 root 3 is 8.7. 8.7 centimeters, 8.7 feet. That's some length, okay? I'm going to multiply this length times the square root of 2. And that gives me 12.2. So 5 root 6 is the same thing as 12.2. Okay, and I'm fine with that answer. Okay, number 12. This is also 45, 45, 90. All right, so what did they give us? This time they give us the hypotenuse. So I'm going from a longer leg to a shorter leg. So that means I must divide by the square root of 2. So x and y, of course, would be the same thing because both of these legs are the same. It's an isosceles triangle. So x is going to be equal to the hypotenuse divided by the square root of 2. Okay, now once again, if you don't have me as a teacher, your teacher may require you to rationalize this denominator, which is fine. So to do that, you're going to multiply the top and the bottom by whatever's on the denominator. So I'm going to multiply it by the square root of 2 over the square root of 2. By the way, the square root of 2 over square root of 2 is just 1. All I've done is multiply by a big fat 1. That's it. So now when you multiply across the top, you get 3 square root of 2. And once again, when you multiply square root of 2 times the square root of 2, that's just itself. So it's 3 root 2 over 2. Okay, that is the radical way. If you want to do it the decimal way for my students, all you got to do is type in 3 divided by the square root of 2 and get some number, 2.1. So I'm going to say or 2.1. Okay. Does that make sense? Yep, 2.1 is less than 3. I'm going from a larger side to a smaller side. Okay, this is the 30, 60, 90 triangle. I see a 60 degrees. That means This other angle has to be 30 when it's a right triangle. So here is our reference triangle for the 30, 60, 90. 30 degrees, 60 degrees. The short side is always across from the 30, okay? So again, we'll just call this X. I'll say short side. Whatever the short side is, everything revolves around the short leg. Okay, you want to get that first. If they give you that first, then that's great. If they don't give you that, then you need to go, if they give you the long, you need to go immediately to the short. If they give you the hypotenuse, you need to immediately go to the short. Whatever the short leg is, the hypotenuse is twice that, 2x. And whatever the short leg is, the long leg is the short leg times the square root of 3. I'll call this long, and of course, that's the hypotenuse. Okay, so what do they give us over here in this 30, 60, 90? They gave me 3. What is that? Short, long, or hype? Okay, that's the short leg because it's across from the 30. So this is the heavenly scenario. That's what we want. This is easy. All you got to do to get the hypotenuse is just double this. Okay, so A is just 6. 2 times the short leg. And then B is just the short leg times the square root of 3. So it's going to be the short leg times the square root of 3. 3 root 3. Okay, if you wanted to convert this to a decimal, you could. So I'll say or 5.2, 3 root 3. Okay, this is another 30, 60, 90. Okay, so now what did they give us? All right, this time they weren't so nice to us. They give us the hypotenuse. Okay, so how do I go from hypotenuse to the short leg? I'm going from a longer side to a shorter side. That means I got to divide by something. If I start here and go here, this is double that, so I got to divide by 2. So B is 5 root 2 divide, whoops, not 5. 5 root 2 divided by 2. Okay. All right, so now to go from the short, so this is the short leg, 5 root 2 divided by 2. Now to go from the short leg to the long leg, then you're going to have to multiply this times what? Short to long, you got to multiply by something. I'm going from a shorter leg to a bigger leg. I got to multiply this guy by the square root of 3. So A is going to be 5 square root of 2 over 2, and I'm going to multiply that times the square root of 3. All right, so when I multiply across the top, I'm multiplying root 2 times root 3, that's just root 6 again. So on top is just 5 square root of 6 over 2. I don't do anything in the denominator. All this is happening in the numerator on top. Okay, if you want to do it the decimal way, here's how you do that. Let's just convert this to a decimal. 5 root 2, 5. Whoops. 5 root 2. Let's just get some decimal. Okay, so the hypotenuse is 7.07. Let's divide that by 2. Okay, so the short leg is 3.5, and then the long leg is this number times the square root of 3. So times root 3, 6.1. Okay, and so all these numbers make sense. 7.7 is the longest side, the short leg is half of that, 3.5. The longer leg is the short leg times the square root of 3. Okay, so that's how you do it if you want to do it the decimal way. Okay, number 15. Number 15. All right, we got a combo problem here. I see a 45 and a 60. All right, that lets me know I'm going to have to do 2 of these. All right, so if that's 45, then that's 45. If this is 60, then that's 30. All right, so I can't do anything with the 45 because I don't have any of the sides. So that tells me I got to start with the 30, 60, 90 first. Okay, they gave me the hypotenuse. Okay, so how do I go from hypotenuse to the short side? I have to divide by 2. I'll put a y right here. Okay, and I'll put a z right here for this side. We got 3 different lengths that we're trying to find. So to go from the hypotenuse to the short leg, I'll divide by 2. So y is just 7 divided by 2, or 3.5. Okay, z is just the short leg times the square root of 3. Okay, so z is just 3.5 times the square root of 3. Okay, again, that's just some number. All right, so now I want x. Okay, so both of these lengths are 3.5 times the square root of 3. Okay, so this length is 3.5 root 3. This length is 3.5 root 3. So let's go ahead and just type that into our calculator and get a number. 3.5 root 3. Okay, that's about 6.1. So each of these lengths are 6.1. Okay, so now if I want to find the hypotenuse of my 45, 45, what do I have to do? I have to take the leg and multiply by the square root of 2. Okay, so I'm going to take the leg. X is going to be the leg, 3.5 times the square root of 3. And then I'm going to multiply that times the square root of 2. So that just comes out to be 3.5 times the square root of 6. Okay, or if you don't want to leave it as a decimal, you could just leave it as the 7/2. You could just say 7 root 6 over 2. If you don't want to do any of that, if you want to keep it with a decimal, then we're just going to take this 6.1 number and do what? Multiply it times the square root of 2. And that gives me 8.6. I'll say or 8.6. Okay, and watch what happens when I type in 7 root 6 divided by 2. Oh, look, we get the exact same number. Okay. All right, one more combo problem. All right, so now we're going to have to start down here at the 45, 45, 90. They gave us the hypotenuse, so I need to put a variable there for y. That means this guy is also y, isosceles triangle. I'm going from hypotenuse to short leg, right? Okay, so what am I going to do? Hypotenuse to short leg. I must divide by the square root of 2. And by the way, how do you remember whether or not to use the square root of 3 or the square root of 2? For those of you who may not have had me, this is the way I explain it. How many different angles do you see in the 45, 45, 90 triangle? You only have 2 different angles. You've got a 45 and a 90. That's it. So 2 angles, root 2. 30, 60, 90 triangle. How many different angles do you have? 30, 60, 90. You've got 3 different angles. That's the root 3. Right, so that's a little trick for how you know. Remember square root of 2 or square root of 3. Okay, so I'm going from hypotenuse to leg, so I'm going to divide by the square root of 2. If I rationalize the denominator, I multiply by root 2 over root 2. That's 6 root 2 over 2. 6 over 2 is 3, so that's just 3 root 2. Okay, if you don't want to do all that, you can just type in 6 divided by root 2, and that gives me 4.2. So I'll say or 4.2. Okay, but they're asking for x. All right, this side right here is 4.2. That's this guy right here. Okay, that's the short leg. Okay, to go from short leg, this is the long leg. So to go from short leg to long leg, I have to multiply by what? Square root of 3. Okay, so up here in the radical, I'm going to take 3 root 2 times the square root of 3. You multiply the 2 and the 3, and that just gives me 3 root 6. Okay, or if we just want to take this 4.2 number, if we're keeping it as a decimal, and multiply that times the square root of 3, and that gives me 7.3. So I'll say or 7.3. Okay, so that's it for the special right triangles. Now let's move on to, oh my gosh, I love this stuff. One of my favorite things in all of math, trigonometry. Tons of real-world application to trigonometry. You can calculate so many different lengths and different angles in the real world with this stuff. It's beautiful. All right, so in these first 6 guys, all they want is, they just want a ratio, okay? So step number 1 is always what? They want the sine of A. Step 1, circle the angle. Step 2 is label. This is my hypotenuse because it's across from the 90, so that's hypotenuse. Students get confused sometimes between the opposite and the adjacent. Well, opposite, if you're standing in your bedroom and you're standing up against one wall, what is the opposite wall? It's the wall that's all the way across the bedroom, right? So it's way over there, the one that's furthest away. Which number is furthest away from A? Is it the 24 or the 18? Of course, it's the 24. So that's my opposite. 18, adjacent. Adjacent means it's literally, this angle is being formed by AC and AB. So AB is adjacent because it's literally touching, making up the angle. So that'll be the adjacent. Okay, SOHCAHTOA. Some old hippie caught another hippie tripping on, yeah, you fill in the A. Okay, all right, so a little inside joke there. All right, so they want the sine. Sine is opposite over hypotenuse, okay? Opposite over hypotenuse. That's going to be 24 over 30. and I need to reduce my fraction. Some of you guys have trouble with this. If you have trouble with that, just let the calculator do all the work for you. Type in 24 divided by 30, get some decimal, and now I'm going to press the math button right here, math. Option 1 is fraction. I'll press enter twice. 1, 2. And that's the same thing as 4/5. Let the calculator do the work. Okay, number 18, cosine of A. Step 1, circle. Step 2, label. Hypotenuse, that's way over there. That's the opposite. That means this is adjacent. Cosine is adjacent over hypotenuse. So that's going to be 48 over 50. Let the calculator do the work. 48 divided by 50. Math, 1, 2. And it's the same thing as 24 over 25. Okay. Number 19, tangent of Z. Step 1, circle. Step 2, label. Hypotenuse, opposite, adjacent. Tangent is opposite over adjacent. So I want opposite over adjacent. 21 over 20. And I can't simplify that. Sine of C. Step 1, circle. Step 2, label. There's my hypotenuse. Way over there is the opposite. Right beside it is the adjacent. Sine is defined as opposite over hypotenuse, so that's going to be 24 over 26, and that reduces to 12 thirteenths. Sorry, 12 thirteenths. Okay, cosine of X. Step 1, circle. Step 2, label. 25 hypotenuse, 15 is way over there, opposite, 20 is touching. Adjacent, cosine is defined as adjacent over hypotenuse, that's 20 over 25, and that reduces to 4/5. Sine of C. Hopefully, as you guys are doing more and more of these, you're getting quicker and more comfortable with it. Sine of C. Step 1, circle. Step 2. Then the reason I have you guys circle it is because if you don't circle, sometimes you can get confused which one is opposite, which one is adjacent. When you circle it, your brain focuses on that. That's all your brain sees, so it's much easier to label. 40 is hypotenuse. 32 is way over there, opposite. 24 is touching. Adjacent. Sine is opposite over hypotenuse. 32 over 40, and that reduces to 4/5. Okay, now we get into the trigonometry. Love it. All right, so find the missing side. Okay, so I'm not thinking Pythagorean Theorem because I don't only have one side. I need two sides for Pythagorean Theorem. I'm not thinking the special right triangles because I got 64. So of course it can't be a 45, 45, 90, or 30, 60, 90. So this tells me I got to use trigonometry here. Step 1, circle the angle. Circle 64. Step 2, label. Now, when you only have two sides, guys, up here I labeled all three because I had three sides. Down here, when you're actually calculating a side, if they only give you two sides, do not label the third side. This is the hypotenuse, but there's nothing there, so don't put an H there. The whole point of labeling is so I can go back to my SOHCAHTOA and say, oh, which one do I have, an O and an H or an O and an A? Okay, so don't circle all three if it's not there. All right. X is way over there on the opposite side. 18 is literally touching the angle, so that's my adjacent. So now I look to see, okay, which of my trig functions has an O and an A in it? Let's go back to SOHCAHTOA. Okay, there's the O, there's the A. So that tells me I'm using Mr. T. Mr. T. All right, so I'm going to use tangent. All right, so I circle my angle. Get my webcam to come back here. Come back. Sometimes my webcam doesn't like to focus. Come on, you can do it. There we go. Welcome back. Okay, so step 1 is circle the angle, then label. So now I'm ready to set up my equation. I already know that I need the tangent, so I'm going to say the tangent of my angle, whichever one I circled, tangent of 64 degrees. And remember, guys, the tangent of 64 degrees is just some number. Okay, it's just some ratio. Okay, 2.1. That means that for every single triangle on planet Earth with a 64-degree angle, the ratio of opposite over adjacent will always be 2.1, no matter if I have a flagpole that's 30 feet high or if I have a triangle that's 3 centimeters long. The ratio will always be 2.1. Okay, that's the whole point of trigonometry. All right, so this ratio, tangent of 64, is equal to opposite, which in this case is x, opposite over adjacent. Okay, guys, when the variable's on the top or the bottom, you only have two different scenarios. I'm either going, just like the square root of 2 with the 45, I'm either going to multiply by the trig function or I'm going to divide by the trig function. When the variable's on top, you will multiply by the trig function. Basically, you're just cross multiplying. Okay, this is like over 1. I'm just cross multiplying 18. So my answer is going to be 18 times the tangent of 64 degrees. Okay, don't ever put the trig function first. Always, when you multiply, always put this guy in front. Okay, let me show you what happens if you don't. If you put the trig function first, tangent of 64 times 18, you're going to get some wacky answer. Okay, you got to put the side first. 18 tangent of 64. Okay, I don't even, let me do that again. 18 tangent, so y'all can see. I don't even need to close the parentheses, and I don't even need to press times right there. Your calculator knows that's multiplication. Okay, so the length is 36.9. Okay, do we buy that? Yeah, not really sure. It's hard to compare because we don't have a hypotenuse, but 36 and 18, yeah, I can buy that. This angle is pretty big here, so I would expect this side to be greater than that side. Okay, let's move on. 24. Step 1, circle the angle. Step 2, label. X is way over there on the opposite side. 10 is the hypotenuse because it's across from the 90. Which one has the O and the H in it? Go back to SOHCAHTOA. O and the H. That's going to be Mr. S, sine. Okay, so I'm going to say the sine of my angle, sine of 19, is equal to opposite over hypotenuse, x over 10. The variable's in the top, so what do you do with these two guys? You multiply. 10 times the sine of 19 degrees. 10 sine 19, bam, 3.3. You buy that? Yep, because it's less than the hypotenuse. Okay, 25. Step 1, circle the angle. Step 2, label. 19 is way over there, opposite. X is touching, so that's adjacent. I don't have anything for the hypotenuse. Which one has an O and an A in it? Tripping on apples, asphalt, whatever. Okay, so I'm going to use tangent. Tangent of my angle is equal to opposite over adjacent. Now the variable is in the bottom, guys. Okay, when the variable is in the bottom, you will divide by your trig function. Okay, if you want to work it all out, you can. You can multiply both sides by x and then divide both sides by the tangent of 34. If you recognize one of our properties of proportions, I can just switch these two guys, right? I can put the x up here and I can put the tangent of 34 down here. So if I put the x up here, I have x over 1. If I put the tangent of 34 down here in my proportion, and x over 1 is just x. Okay, that's why, guys, I say there are only two different options. You're either going to multiply by the trig function or you're going to divide by the trig function. And all you have to remember is where's the variable. Variable's in the bottom, trig function's in the bottom. Variable's on the top, trig function's on the top. You're multiplying. So on my calculator, I'll just simply type in 19 divided by tan of 34, and I get 28.2. Do you buy that? Yeah, I buy that. Yep, 28.2. Yep, sounds reasonable to me. 26, step 1, circle the angle. Step 2, label. X is the hypotenuse across from the 90. 18 is way over there on the opposite side. All right, O and a H, that's going to be sine. So I'll say sine of my angle, sine of 28 is equal to opposite over hypotenuse. Where is the variable? Variable's in the bottom, so the trig function's in the bottom. So 18 divided by sine of 28. 18 divided by sine of 28 gives me 38.3. Okay, do you buy that? Yep, I buy that because it's bigger than the leg. So that makes sense to me. Home stretch here, guys. Home stretch. I know this is kind of a longer video, but this stuff's a little bit tricky. I love it, but it can be a little tricky. All right, so step 1, circle. Step 2, label. That's the hypotenuse. 20 is touching it, so that's the adjacent. Which one has adjacent hypotenuse? That's going to be cosine. So I've got cosine of my angle is equal to adjacent. Oops. Adjacent over hypotenuse. Where's the variable? Variable's on the bottom, so the trig function goes on the bottom. 20 divided by the cosine of 69, and that gives me, to the back. That gives me 55.8. Okay, step 1, circle. Step 2, label. 16 is way over there. X is touching. There's nothing for the hypotenuse. O and an A is tangent. Tangent of my angle is equal to opposite over adjacent. Where's the variable? On the bottom. So trig function goes on the bottom. That comes out to be 41.7. Circle the angle. Label. X is on the opposite side. 15 is touching. There's nothing on the hypotenuse. O and an A, that's tangent. So tangent of 65 equals opposite over adjacent. Where's the variable? Variable's on the top, so the trig function goes on top. You're going to multiply these two things. 15 times the tangent of 65. 15 tangent 65. 32.2. Okay, last one of these. All right, so step 1, circle. Label. X is the hypotenuse across from the 90. 13 is way over there on the opposite side. So that tells me I got to use sine, opposite, and hypotenuse. Sine of 20 degrees equals opposite over hypotenuse. Variable's on the bottom. Trig function's on the bottom. And that comes out to be 38.0. Okay, that's trigonometry. That is when you're finding a a side length. Look at all these problems, guys. Where's the x? Outside the triangle. Where's the x? Outside, outside, outside. Okay, when the variable is on the outside of the triangle, you are finding an actual length. Okay, that's normal trigonometry going forwards to find a length. Now look at these next few problems, and now notice where the variable is. The question mark. It's inside the triangle. Inside, inside. When the variable is inside the triangle, you are finding an angle. Okay? So when they give you two sides and you're finding an angle, you must use the inverse trig functions. Okay? Okay, so let's start here. The steps are the same. So step 1 is circle. Step 2 is label. 13 is way over there. 24 is the hypotenuse. O and an H, that tells me I got to use sine, but now I'm going to use the inverse sign, guys. Inverse, and look on your calculator. See the sine button? Right above it in blue is the -1, cosine -1, tangent -1. Those are inverse trig functions. When you're calculating an angle, you've got to use the inverse. So it's going to be inverse of opposite over hypotenuse. 30 over 24. So my calculator, that's literally the way I'll type it in. I got to press the second button, second sine. Make sure you see that little -1 on your calculator. Inverse sine of 13 divided by 24. And that back calculates my angle, 32.8. Okay, so 32.8 degrees. Okay, I'm going to go through these last few ones pretty quickly. Bell's about to catch me here in just a couple of minutes. Step 1, circle. Step 2, label. That's my hypotenuse. This is on the opposite side. There's nothing here on the one touching it. There's no adjacent there. Opposite and hypotenuse is sine. So once again, it's the inverse sine of opposite over hypotenuse. Type that in your calculator. Second inverse, 38 divided. I don't even need to close the parentheses. 64.8. Technically, these say round to the nearest degree, so I guess really and truly, I should be 65 degrees. Okay, all right, so number 33, circle, label. All right, so that's also going to be sine, inverse sine of opposite over hypotenuse. And that comes out to be 32 degrees. Circle, label, way over there, the opposite, 27 is touching, that's adjacent, there's no hypotenuse. So now opposite and adjacent, look at your SOHCAHTOA, I need tangent. So it's the inverse tangent of opposite over adjacent, 17 over 27, and that comes out to be 32 degrees. 32 degrees. Also, again, if you type something in wrong, sometimes I see students that will get an angle of like 0.02 degrees, okay? Does that really make sense, 0.02? So always ask yourself, does your answer sound reasonable? 30 degrees, 64 degrees, those reasonable angles. Step 1, circle. That's my hypotenuse, that's my adjacent, A and an H. I'm going to use the inverse cosine of adjacent over hypotenuse. Type that into your calculator, you should get 56 degrees. Circle, 26 is way over there, 36 is touching. We have no hypotenuse, so that's tangent. Inverse tangent of opposite over adjacent. That comes out to be 36 degrees. Sorry, can't see that. 36 degrees. And the last couple here. Step 1 is circle my angle. Step 2 is label. 11 is way over there. 23 is touching. I have no hypotenuse, so that's cosine. So that will be inverse cosine of opposite. Oh, wait, hold on. Whoop, almost made a mistake there. Sorry. Trying to hurry up since the bell just rang. O and an A, that's going to be tangent. Sorry. Inverse tangent of opposite over adjacent. Type that into your calculator. You get 26 degrees. And the last one here, circle, label, 33 is touching, 41 is across from the hypotenuse. That's across from the 90, that's your hypotenuse. A and an H is cosine. Inverse cosine of adjacent over hypotenuse. And that comes out to be 36 degrees. Okay, so guys, with trigonometry, make sure. Sorry, this announcement's going on. Grace Gomer, Aaron Garnett. I'm sorry, that's Aaron Gravitt. Neva Go. We need you in the front office. Thank you. Okay, sorry about that, guys. Just remember, guys, with trigonometry, please follow the directions I've given you. Step 1 is circle the angle. Please label everything correctly. Take 5 seconds, 10 seconds, and make sure you label those things correctly before you figure out whether or not you got to use sine, cosine, or tangent. All right, hope you guys enjoy this video, and we'll see you on the next one.